Sketch2Terrain, AI-driven real-time terrain sketch mapping in augmented reality. Cognitive map is a mental representation of spatial environments. Sketch mapping is widely used to externalize cognitive maps. However, current sketch mapping methods mainly rely on 2D drawings, making it hard to depict 3D features like terrain elevation. With immersive technology, we can create 3D sketch maps directly in 3D immersive environments. This paper focuses on 3D sketch mapping of natural terrains and presents Sketch2Terrain, a generative AI-driven real-time 3D sketch mapping augmented reality interface. Sketch2Terrain empowers non-experts to create unambiguous sketch maps of terrains and provides a homogeneous interface for researchers to collect data and conduct experiments. The workflow for Sketch2Terrain is as follows. Firstly, users are asked to observe a terrain model and memorize its structure. Second, in this sketch mapping task, the terrain model disappears, and users use Sketch2Terrain to draw the spatial environment from memory. A generative AI model is developed to convert the 3D strokes into shapes for better visualization and to facilitate easier and faster recalling. The user iteratively repeats the drawing for a more accurate result. Here, we demonstrate the training data collection mode, which helps researchers prepare data for AI algorithms. In this mode, researchers can generate a random terrain model by pressing the Next Terrain button. Strokes can be snapped to the terrain surface within a specified threshold to improve data quality. We integrate a Pix-to-Pix model into our sketching system due to its fast inference speed, suitable terrain accuracy, and compact size for real-time performance. We conducted a comparative user study with 36 participants between 2D, 3D, and generative 3D sketch mapping interfaces on memorizing 8 terrains. From left to right, we present an example sketching task using 2D, 3D, and generative sketch mapping interfaces, respectively. After observing a terrain model for 2 minutes, participants had 5 minutes to sketch on an empty workspace. Participants use one of the interfaces to create a sketch map from memory, incorporating both terrain structure and the locations and shapes of landmarks. Experimental results showed that generative 3D sketch mapping improved efficiency, terrain topology accuracy, and landmark accuracy, with only a slight reduction in terrain elevation accuracy, compared to freehand 3D sketch mapping. Additionally, generative 3D sketch mapping reduced perceived strain and stress, compared to 2D sketch mapping. These findings underscore the potential of generative 3D sketch mapping for applications such as search and rescue, accident scene reconstruction, and dream cartography. For detailed results, please refer to the paper. Thanks for watching.